G'day guys, let's get comfortable. Had a weekend working on 7,000 detectors, and it's been a very interesting experience, and a few things that are probably very interesting to people that own these detectors. They are a very interesting device that it is just about impossible to fire one up in your house and try and do any work. It's just a massive bucket of noise. So I've got a trick to quieten the detector down so you can actually work on the receiver side of the detector, that it's just not getting hammered with noise. And yeah, it worked out quite well in the end. I've got one detector here. This one is done. I had to do a few little tricks of the trade to this to quieten it down a little bit, but we can we've got this module worked out now, so we can actually isolate that module and feed in on another point with a complete separate preamplifier, or you can use part of it still there and add more. It's very, very important that you don't try and add heaps of gain into this, because the detector will stop functioning. There are other ways to make it quiet, and it's more to do with impedance matching than anything else. So we have the board in there. I've tested it, and this one is ready for field trials. So I've got another one. I'm just leaving it standard. I'm going to set them up the same settings, and out we go. But we have to try it on hot ground, so forth. But I've got to show you a few tricks. So I'll leave the video running, but just bear with me. I'll put this back together so it's not completely back together, but I mean electrically, so I can show you that it works. Learned a lot about the 7000. A few things I didn't know, and I think I found a few things that other people don't know as well. It's very critical in some of the placements of wire, and yeah, just stick it all, ensure that goes in nice. I don't want to do anything dastardly, so I've got that. I've got to connect up the mylar strip, the thing I was telling everyone to be very careful with. Get the battery things in there for a sec. You don't want to, hang on a sec, I just got to rearrange this a little bit because I want to put it between the coil and the head cables, like so. Get a bit of room, keep it standing up, and gently lift those tabs and make sure that mylar's all the way in, and push the tabs down. Okay, we've got the mylar. I need a battery. That would help, wouldn't it? That's right in front of my face as usual. So one battery. Again, work in a way that you don't stress out that mylar. A lot of people are very, very interested in how this detector came up. So I'll get the audio amplifier. I'll turn him up. Now this is the interesting thing with this detector. I've got it on a sensitivity. Oh, I've changed it, but I did have it on a sensitivity of 1, just 1. And the amount of noise, electrical interference, you can't do anything. But I'll give you an idea anyway, but I'll show you how to shut it up. Right? So anyway, we'll turn him on. and go for all these checks and balances. Wait for the noise. Actually, I've got the sensitivity on 17. I was just trying some experiments. So that is going to have to go down. There it goes. So it'd be impossible to try and do anything with that amount of noise. Okay, where are we? Oh, that one. Down. I'll just drop the sensitivity down. It's on 17. I'll drop it down to 1. And it's made a little bit of difference, but not much. And I'll show you a trick if you want to shut these things up to work on them. You can't work on it with that much noise. You'll never be able to make noise figure measurements or anything. It's just if you disconnect the coil, it doesn't work. And some more interesting things on that too. So I'll show you. I'll just move this tripod over here, and we'll stick it on the coil. Now what I've got, hope you can see. Now I've got to lower it down a bit more. I've got a couple of ice cream containers, commercial ice cream containers for shops, so we'll just drop this down a bit. Now, I'll show you what I've got here. These two tubs here are just full of air. They're just empty, right? So I've got the coil sitting up there. Under that second tub, I have some copper fabric. That's copper fabric, big long piece of it. Now what I do, I get these, I should use 2. I get the copper, and it probably won't stay there, will it? Is it? No, it won't. It wants to slide off. It's very slippery. I'll just put my stick there. Oh, if you can see, or more like here. Okay, I haven't got a complete shorted loop around. I don't think it would be a good idea to do that, but just putting enough conductive mesh around the coil like I've done there shuts it up. Right now, you think it's completely desensitized and dead. It's not. It's a nice hunk of metal. If I actually get this, and I'll turn this up so you can hear. I went the wrong way. Here we go. Have a listen to this. Doesn't like me touching that, but anyway. I'll probably change some operating parameters in the detector. But I've measured, there's no strange, scary things happening in the detector that's going to cause a voltage problem on the input or anything like that. Transmitter doesn't care. It just stays running as cold as it did. There's no excess spikes on or any voltage, any strange flyback or anything like that. There's no nasty artifacts happening by doing that. It's probably like sticking the coil in pure ironstone, but a bit worse. So do that. You can make the detector quiet, that you can actually work on the electronics. So get back onto the detector. Loosen that off again. So we got our detector working away there. Actually, I'll drop the tripod down a bit to get it level, so I can show you some of the stuff on the oscilloscope. But yeah, I don't edit my videos. I just run them as they are. They're rough. So what you see is what you get. No, smoke comes out, you'll see that as well. not likely, but never know. Actually had a pair of needle nose pliers one day. I was working on a GPX Extreme, and oh, up here I had the tools sitting up here, and I grabbed something else side onto it, and it's caught it. It's come down and landed straight in the GP Extreme, and it I think it blew something up. I can't remember, a long time ago. Oh yeah, it took out one of the regulators. Um, so anyway, haven't done that. I haven't done that again. So that's that. Okay, so we've got this detector. It's actually on at the moment, but it's very, very quiet. Still working, is it? Still working. Um, but if you want to actually look at the waveforms, I'll just get the oscilloscope connected up here. Yeah, good ground point. Okay. That one or that one? That there, I haven't got it locked up properly, but that's the output from the receive module on the board. And if you actually, if I took this copper material away, those curved waveforms would probably straighten right out. That's the bipolar signal from the transmitter. It's just coming back through the receive coils into the receiver and being amplified. I just look at the input from the coil without no amplification. I don't even know. Well, the detector hates that, doesn't it? But yeah, we'll go down to here. That's at 2 millivolts a division, and that's what it is. That's how it's coming in. Those flashes there, if they're syncing up with the camera, vertical flashes, that'll be 50 hertz getting into it. But there are some other interesting things. I'll show you. I'll take this off because it just makes it noisy. But you can go on the output there. That's my board I've put in. That's the output from my board. But there's a lot of noise still, just because of the room environment. Now, we're on 2 millivolts a division. What I've done is I've actually just made the oscilloscope probe into a small loop. So it's a pickup loop. I should bring this closer, so I don't know if I can. I've got too much stuff on the floor. Hang on a sec. I'll get it in. I'll maneuver. We'll get it in. I'm pretty close to the coil too. It might have a problem. But if I have a look on the oscilloscope when I take this near the transmitter stage. But what's very important, this is a ripper. This one. This is one of the switch mode power supplies, and you can just see the amount of artifacts it's generating. I think it's they look like they're probably on the transmit waveform timing of the detector, so it's probably no big deal. But the one that got me, this small one over here, hold on to your hats, but look at that there. That's a hell of a lot of stray radiation there, and it's across the whole spectrum. It's across the whole near me, the whole timing cycle of the detector. So I've actually put some magnetic shielding material there to. It actually has helped, and I don't want that going into the receiver, but it's there. But it does drop away as you get towards the receiver module, which is the most sensitive. There's a few little increases in noise there. You can see the center line. We've got a bandwidth at the moment of, I'm not sure if it's 20. I'll just check what the bandwidth is. Okay, we're running a limited bandwidth for 25 megahertz. So if we go down here near the receiver, don't worry about those transmit pulses. They're not going to get in there. But you can see a little pulse beforehand. That's from that switch mode supply at the top of the board. You can see it dipping down the bottom there. I hope you can see it. I can. Don't know about the angle of the camera. You should be able to see it. And move it over here, disappears. Move it along. But you can see that the noise does come up and it drops away. If I did something like this will be an eye-opener. Say I raise the bandwidth to 200 megahertz and I went near this again. You can see the noise increasing. Lucky our detectors are low frequency devices. They're not running up that high. So it probably may raise the noise floor a little bit. Get over here, and then there's that switch mode picking up there, and this one here. This will probably be a shocker too, but there's this one again. Oh, look at that! Fills the whole screen up. So the noise coming out of here, if you look at that, it's well above 25 megahertz anyway. It's 200 megahertz bandwidth, and we get all this noise. That's just astronomical, finding that inside the metal detector, but it is what it is. I'm not, and again, this is for education. That power supply there, this device under here, it looks like an inductor, a standard inductor, but it's actually a transformer. I tracked that out. It's a transformer, so there's a lot of flux leakage, magnetic flux leakage, not flux as in soldering. Oh, and for the Americans, soldering. For the English and the Australians and half the world, soldering. And the Americans say soldering. It's a silent L for some reason. So why don't you spell it SOD, double D, SO double D, the sod, ERING. It's always got me that, It's like people who say xenodiode, and then you got other people who say xenodiode. Was it E and an E? What about New Zealanders? They probably call it a xenodiode. But I don't know. Just fun with words. But anyway, that's a lot of noise coming out of there. And if this wasn't a solid ground plane type design, this would probably travel through and get into the receiver in a big way. But there's fractions of noise getting there. Is it an issue? I really have to come up with a way of making a phantom coil for this, and then measure the receive lines and what comes in, what comes out. Just do some comparisons on noise levels and so forth. That would probably take a good week of mucking around. The main criteria is this input receive line here, this black one. You can see that. I think I've got it on there. It's okay to see. You know, this could be double end shielded to or connected to ground. I haven't done it, but when I used to make high frequency boards, what I would do if I had a cable that had low level signal come in, like this one here, it would be grounded up where it goes, but I would also strip the insulation off and ground the outside braid to various ground points on the circuit board, especially if it had a ground plane. And that is what I would do when I was working with radio receivers or even transmitters. I would never leave a floating wire. I mean, it's not a radio transmitter or receiver, but you could look at it the same. And would it help grounding it where it comes in here on the board and grounding it in the middle and grounding it here again? I don't know. You know, just it's something you could probably experiment with. It's only a small piece of coaxial cable, so you could strip it back and do all this sort of experimentation. And if it didn't work out or increased noise or something else happened, created some strange results, you could just replace it. It only goes on to one of these plugs here. There's nothing hard about it. But yeah, so I hope all you experimenters out there like the idea of that mesh that I have stuck near around the coil and getting caught up on wires on the floor. I think that was rather a lucky guess at doing that to see if I could, stop it making all that horrible noise and basically um, jamming it up electrically. But like I say, you take this off and that's what you got. But I have done, even with that noise, we'll just leave that noise there for a second, right? And I'll just get this up again. I'll take off the ice cream containers off the coil. I've got the other board in there at the moment. There's no increase in noise between running the standard board or the my board on there. But one thing I did notice, that's just a ring, trying to battle the noise on a sensitivity of 1. I have noticed that I did measure before and after that I can actually get more distance with my board in there. And like I say, it's not adding gain, it's lower noise input and changing the impedance. There's reasons for that, but I'll just turn that noise off because it's overbearing. I don't even think you could. I'll just turn it up a little bit so we can hear it. But if I pick up the coil, and no matter what I do with it, it's just going to make noise. Sometimes you can orientate the coils perpendicular to the noise source, and the noise will go away. But it's 50 hertz; it's everywhere. So it's just the power cables going through the house is causing all this problem. Yeah, it's going to detect that copper there, but that's all right. I'll kill that. I'll turn it off. It's just too noisy. So that's where we are with the 7000. So the next video that you'll see, I'll put this back together, and it's raining at the moment. It's also 4:30, and it's raining outside, so I can't really go and do any testing. Let's throw this tripod back over there a bit. I can't do any testing, and if I had a look at the weather, and it looks like we're in for some continuous drizzle for a few days. But I might have to look further afield, maybe go north, go for a drive, take the detectors up there, and try them out up north. Hopefully, there's no rain. If we can get up, a few miles away from Rain Central. This Ballarat, for some reason, uh, it's it's shaped like it's ringed by hills, and it's sort of a depression, like a valley. It must have been a big valley because I think it's where we are. It's got layers and layers of basalt from volcanic flows. That's why there's tons of gold here. It was all trapped in the basalt layers, and it goes down to a pretty steep into a point, like a big valley, like so. And I think we're 250 feet above, but we're still it's still a valley as such, because you come down into it. And imagine before the lava flows, it would have been a great big valley, and there wouldn't be a town here, and there wouldn't be any gold either, probably. So if you didn't have the volcanic effects. But yeah, this is one hell of a rich, deep um, gold field. Um, Still gold everywhere. What gets me is they built houses over most of the gold field, you know, and I pulled gold from just up the road in the clays. So you got so much gold field here, and it's just covered up with houses. And I think there was a report that someone did that they said the main town where the main buildings went up, in the 1850s, 60s, 70s, and 80s, is where the main gold lodes are, is actually under the towns. Yeah, it's a problem. But our local, one of the local gold companies here, Ballarat Goldfields, it's had various names. It was listed on the stock exchange, and you know, it didn't run a profit when it was on the stock exchange, but as soon as it went to private ownership, it did. Hmm. Okay. Yeah, they were doing a lot of dynamiting and blowing things up underground and rattling people's houses. And one of the guys that worked there said they came across an area and stoped out a hell of a lot of gold. Yeah, under the Canadian area, I think it is, which is basically where I am. So yeah, we've got little areas of Ballarat. You got Eureka, where the Eureka Stockade was, and Eureka Gold Rushes. Uh, Here is called Canadian. Obviously, it was probably full of Canadian diggers, and you go around the place and you got you know all sorts of different names. Redan's another area, and whatever that means. Sebastopol sounds like something over in Europe. Uh, just different areas around the place. A lot of gold came from this an area called Brown Hill and Black Hill. Black Hill was full of gold, and they sluiced it. It's got massive cutout in that hill. Anyway, rambling on about a history lesson here. But yeah, still a lot of gold around Ballarat. A hell of a lot of gold around Ballarat. If you go through the Canadian diggings, there was the Canadian lead was very rich. But if you go through the history books, most of the gold's down on top of clay at a distance of between 20 and 40 feet. So no good for metal detectors, but it was good for the miners. Dig a hole and get down the bottom, scrape it out, and you know, hopefully you landed on a nice pile of gold. That's how it all used to work. Anyway, The next videos I'll try and get out in the field. Unless something else pops up and it's of interest, I'll make another video. But I know a lot of people want to see how the 7000 goes after modifications, how it handles the ground, how it handles noise. I mean, I can't prove anything here. They're both going to scream in this environment, so I need to get out. I'll probably we'll try encroaching on some power lines and just see if a detector is more receptive to noise or not. And yeah, you can all draw your own conclusions from the field tests. So yeah, got one going, got one there, standard. We'll go and do the tests. That's 30 minutes of waffle. Yeah, hope you're all getting gold. Catch us later.